Hi, welcome to Regents Chemistry Review. I'm Mr. D. During this lesson, I will review some of the factors that will affect the rate of a chemical reaction. In order for a reaction to occur, reacting particles must first collide. If the reacting particles are in the proper orientation and possess sufficient energy, then a chemical reaction will indeed occur. These types of collisions are called effective collisions. Additionally, systems in nature tend to move towards conditions of low energy and high entropy. This means that exothermic reactions are more likely to occur than endothermic reactions, and reactions forming less ordered products, such as gases, are more likely to occur than reactions that form more organized products, such as solids or liquids. In general, reactions that release heat energy, where the heat of reaction, the delta H, is negative, and form gases where the delta S value, the entropy value, is positive, will have a much faster reaction rate. Now let's review some of the factors that will affect the rate of a chemical reaction. Nature of the reactants. If the reactants contain covalent bonds, the reaction will be slower than if the reactants are ionic compounds that are dissolved in aqueous solution. The nature of the products, however, are not important when observing the initial reaction rate. Temperature. Temperature will definitely affect the rate of a chemical reaction. Consider this hypothetical reaction that is occurring at 25 degrees Celsius. Increasing the temperature increases the average kinetic energy of the reacting particles by causing them to move faster. So increasing the temperature increases the frequency and effectiveness of the collisions between the reacting particles, which in turn will increase the reaction rate. Concentration. Increasing the concentration of one or more of the reactants will increase the number of particles that are actually available for effective collisions to occur. And of course, this will in turn lead to an increase in the rate of the chemical reaction. Surface area. Grinding or dissolving reacting particles in water will provide more surface area for effective collisions to occur. And of course, more surface area leads to a faster rate of a chemical reaction. Pressure. Pressure will significantly affect the rate of a homogeneous gaseous system. Increasing the pressure forces the reacting particles closer together, and in general will favor the side of the reaction that has the fewest number of moles. In this example of the Haber process, the forward reaction is favored due to the 3:1:2 molar ratio, where the product side will have the fewest number of moles. Therefore, the product side is favored. So, increasing the pressure increases the frequency and effectiveness of the collision between the reacting particles. And of course, this will lead to an increase in the rate of the chemical reaction. Adding a catalyst. Adding a catalyst will increase the rate of a chemical reaction by lowering the activation energy. This provides an alternate pathway for the reactants to follow, thus increasing the rate of the chemical reaction. Now for some Regents practice, consider the following questions. Raising the temperature speeds up the rate of a chemical reaction by increasing: number 1, the effectiveness of the collisions only; number 2, the frequency of the collisions only; number 3, both the effectiveness and frequency of the collisions; or number 4, neither the effectiveness nor the frequency of the collisions. Increasing the temperature will increase the average kinetic energy of the reacting particles. Therefore, the correct answer to this question is number 3, both the effectiveness and the frequency of the collisions. At STP, which 4.0 gram sample of zinc will react fastest with dilute hydrochloric acid? Number 1, lump. Number 2, powdered. Number 3, bar. Or number 4, sheet metal. Well, one way to increase the rate of a reaction is by increasing the surface area. To do this, we may grind the reacting particles into a powder. So the correct answer to this question is number 2, powdered. Which statement best describes how a catalyst increases the rate of a reaction? Number 1, the catalyst provides an alternate reaction pathway with a higher activation energy. Number 2, a catalyst provides an alternate reaction pathway with a lower activation energy. Number 3, a catalyst provides the same reaction pathway with a higher activation energy. Or number 4, a catalyst provides the same reaction pathway with a lower activation energy. Now clearly, choices 3 and 4 make no sense. Okay, so the choices are between number 1 and number 2. Now, when a catalyst provides an alternate reaction pathway, that pathway will have a lower activation energy. So the correct answer to this question is number 2. Base your answer to the question on the information and potential energy diagram below. Which lettered interval on the diagram represents the potential energy of the products? Now, to answer this question, consider the reaction coordinate. This simply means that the reaction proceeds in a forward direction. And if that is true, from your knowledge of a chemical equation, you know that the products will be at the end of the reaction. So the correct answer to this question is D, where D will represent the potential energy of the products and A will represent the potential energy of the reactants. Which sample has the greatest entropy? Entropy represents disorder, and entropy increases from solid to liquid to gas. So in this particular case, we have choices between number 1, ammonia gas, number 2, ammonia solid, number 3, liquid ammonia, or number 4, aqueous ammonia, where the formula for ammonia is obviously NH3. The correct answer to this question is number 1, gaseous ammonia. Okay, this concludes my review of the factors that will affect the rate of a chemical reaction. Hopefully this video has been helpful. And remember, should you require more assistance, feel free to visit my Facebook page at facebook.com/WPHS Chemistry. Thanks for watching, and good luck on your upcoming examination. I know you'll do well. Take care.